And I'm sorry to do this to you again. It appears that at the end of 13.3 we cut off right here before the finish. So in this end of 13.3 we were looking at finding all the real zeros for this polynomial 6x cubed plus 23x squared minus 83x minus 30. So we started by identifying the possible rational zeros by looking at the factors of the constant term divided by the factors of the leading coefficient. We then looked at our graph and identified some likely candidates based on what we saw in our picture. And we decided to start with -6. So when we did our first round of synthetic divisions, we got remainder 0 when we used -6, which is good. So that tells us we have the factor x plus 6 times the factor 6x squared minus 13x minus 5. If we're looking to find the zeros for this function, now that we have it factored into linear and quadratic pieces, it's very solvable. So to find the zeros, I'm just going to take f of x and plug in 0 for it, or replace f of x with 0. So I'm going to solve this equation equal to 0. I think I wrote -15 there my first time through. That should be -5. And then if I apply the zero product property, I can have x plus 6 equal to 0, and 6x squared minus 13x minus 5 equal to 0. Solving the linear equation is really easy. To solve the quadratic equation, I'm going to use the quadratic formula. So when I plug everything in, I get 5 over 2 and -1/3, which again, if I went back and looked at my possible rational zeros, were things that are on my list and were observed from our graph. Now be careful when doing this kind of a problem. When you factor this, you may have to do more than one division to get to linear and quadratic pieces. That's okay. Second thing to look out for is that some of these divisions may have to happen more than once. Like you might have to use -6 more than one time. That's possible. And the third thing to happen is don't just look at the graph and go, oh, these are the numbers I would have gotten from the graph, and be done with it. If that's the case, you'll miss a multiple solution. And you could possibly miss, or you would certainly miss imaginary solutions, right? Like this quadratic equation, solving this, you could get your answer in terms of i's, and the only way to get those imaginary answers is to actually do the factoring. You can't just look at the graph and find the x-intercepts and go, oh, there's my answer. And the expectation on the test will be that you're able to do this algebraically. So you should be able to kind of write out these steps in terms of how you get to your answers and not just give me a list of answers. Okay? But I think that's all that we're missing. So you should be all set now. Thanks.